All right, so today we're going to take it. Now, we just reviewed on the board all the steps for factoring. And today we're going to talk a little bit more about trinomials and other types of values when things get a little more complicated and people don't see them. Now, I'm going to tell you right now, you are good at factoring if you can factor and we put in silly symbols. Okay? If you can really look at something and do silly symbols. Let me give you an example of this. What if I gave you something like this? Sine x squared minus 4. A lot of you are like, you put trigonometry in there. Stop for a second. Ask yourself this question. Do you have a greatest common factor? No, because is there a sine x over here? No, there's not one before. So do I have a greatest common factor? No. How many terms do you have? What's so special about those two terms? They're a difference of what? Difference of squares. Because the sine x is being what? Squared. And the 4 is a perfect square. Would you guys agree? So could I sit there and just go sine x plus 4, sine x minus 4? Oh, not 4. Hello? I saved it. 2. Got myself there. 2. Hey, it's morning. All right. My caffeine is already wearing off. All right. So, guys, was it really that difficult? Oh, what if I gave you something like this? Let's go heart cubed minus square cubed. Do I have a greatest common factor?
Yeah. Oh, no.
Do I have something that can come out of both terms that are the same? What? Can I take something out of both of these? I have a heart cubed and I have a square cubed. Guys, are those the same? No. Okay. Now you go, right? There's no greatest common factor. What do we do next? Count terms. How many terms? Oh, what are those? Those are difference of cubes. So difference of cubes goes into a binomial and a what? Trinomial. So binomial, trinomial. Using SOAP or San Diego Padres, whatever phrase you do. What goes in the first one? What does S stand for? So that has to be subtraction. What does O stand for? And then last one, AP, always positive. Excellent. All right, now put the stuff in. What's the cubic root of heart cubed? Heart. What's the cubic root of a square cubed? Okay, what part, are you seeing this isn't any different than what we were doing? All right, what goes in for my first term? Okay, what do we have now for our middle term there? What do we go for our last one? Squared. All right, a squared. Okay. Why are we making this hard when we have symbols? We don't. Okay? So when you are working with trinomials and stuff, you should still be able to go through, even if it's different than what we've done, as long as our terms are the same count, we need to try stuff. So like right here, we have square squared plus 4 squared plus 3. Is there a greatest common factor? No. All right, how many terms? Oh, what do we have to try? Yeah, logical trial and error. So we put our 2 parentheses down. Now, looking at our signs, we still need to practice this. There was a few errors on here. Overall, doing pretty good. If it's addition at the end, it means same what? Same sign inside our parentheses. What are they both going to be? All right, addition. Great. Okay, factors of square. Square and what? Square. Factors of 3. 1 and 3. Now, talk to me. Why did that seem so hard? Now, should I check to see if we're right? Yeah, let's check it. So we go our outside. That's a positive 3 square. Inside, a positive 1 square. Guys, what's 1 square plus 3 square? Oh, did we do it correctly? See, why do we get freaked out when we get weird symbols? Because did the rules change? Okay. Now, what would happen if I throw something in there a little bit different? What would happen in this problem if I turn around and I put an x squared? So, I want you to think about what happens. How many terms did I still have? 3. What do we try? Yeah, we're doing logical trial and error. And what we got earlier, here's my 1, here's my 3. We had our boxes here earlier, but what goes inside the boxes this time? All right, now you ask yourself a question. How many terms? How many terms inside the parentheses? 2. Is it a difference of squares or some are difference of cubes? X squared plus 1. Is that a difference? No. So can I go further on that one? X squared plus 3. Can I go further with that one? No, because does it fit in difference of squares or some or difference of cubes? It has to follow in there. But guys, look at what your final factoring is. It's just x squared plus 1 and x squared plus 3. Oh, you mean I might actually have squared terms and things like that, or cubed, or whatever, they're crazy? Yeah. My answer to that is so. You should still be able to do it if we follow our factoring rules. Now, some people do better when they can give themselves a little bit of a visual, like being able to do what's called the U substitution process. Now, I will tell you right now, my pre-cal students like this method. They're just not good at using this method. I personally never use it because I think you guys are able to do it without. And I'm going to show you both ways and just see which one works best for you. Are you guys with me? Okay. So when we use what's called the U substitution method, is you replace something inside your original algebraic expression. Now, when we look at this, we're like, oh, there's no greatest common factor in there, right? But notice, I'm not used to having a middle squared term, correct? So guess what you're going to do? You're going to go, let U equals a squared. Now, if that's the case, what does a to the 4th become? That becomes u squared, right? Because that's really a squared meaning what? Squared. Are you seeing what we just did with the u? And then we go minus 2u minus 3. Factor using the u. So if you factor using the u, would you guys agree with me? This is 3 terms. What are my signs inside? Yeah, plus minus, because we have subtraction here. We're going to go plus and a minus. Well, u squared, what are the factors of u squared? U and what? Factors of 3. We got 1 and 3. Okay. Now, what do? Guess what I plug back in? I have, because my original problem, did it have a u in it? No, I need to have a what in there? A squared. So you plug it back in. You substitute it back in. So you get a squared plus 1 plus body a squared minus 3. Then ask yourself, have I factored completely? Looking at each term. First one, a squared plus 1. How many terms? Is it a sum or difference of cubes or a difference of squares? So are we done? All right, a squared minus 3. How many terms? Is it a difference of squares or sum or difference of cubes? Good. Right? Yes, sir.
How is that not a difference of squares?
Because 3 is not a perfect square. What are your perfect square numbers?
Oh.
1, 4, 9, 16, right?
47.
Yeah. So like we've got, now watch it not erase it. Yeah, so make sure you have your perfect square numbers, all right, when you are working with it. Now, here's the thing. I don't need this. When I look at a to the 4th minus 2a squared minus 3, I still see 3 terms. I still think I'm going into a binomial. But when I see this a squared here, what does that let me know the factor of a to the 4th is going to be? I know I'm going to have an a squared and an a squared. So I can go straight there because I know how squaring works. And then you still have your plus and your minus, and you still have your factors of 3. Notice for me, I don't need to take the time, because I understand that a squared is being what? A to the 4th. So anytime that I see a middle term like a squared or something in that manner, I always go, oh, is that really my factor? But I think for some of you, the substitution method is going to work really, really nice for you. I think it's going to work great because you're going to have a way of kind of keeping the complicated numbers away for a little while. But you have to still be good at understanding squares and cubes and all those type of things. All right, so we're going to try these using new substitution. I hope your brains don't get too scary when we're doing this, but I think you should be able to do a pretty good job. Okay, on this first one, we have a to the 4th minus 2a squared minus 48. All right, with this one, again, a lot of people freak out, but we know it is 3 terms, so we're still going to have to try our logical trial and error. But I don't have a squared term. I have a to the 4th. So what do? Let u equal what? A squared. Because really that's just a squared meaning what? Squared. And then we re-put it in there. So we go u squared minus 2u minus 48. Then we sit there and go, okay, no greatest common factor. So 3 terms, we're going to do logical what? Right? And so we have our subtraction is going to be what? Plus minus. Okay, guys. Factors of u squared. U and u. Factors of 48. Here's the thing. If you need to sit there and write them out. Which one are we going to try first? I'm just going to throw in 6, 8. Did we put it in the correct spot? That's a negative 8u, positive 6u. Did that give us a negative 2u? All right, so we did that correct for that step. Now what do we have to do? Because if you stop here, I'm going to have to count it wrong. We have to put it back in. So now we plug in and substitute in our a squared. So when we do that, we go a squared, it's not with a highlighter though, a squared plus 6 times the quantity a squared minus 8. Okay, then you ask, can I go further? A squared plus 6, can we go further with that? No, because it's 2 terms and it's not a difference of squares. A squared minus 8, can we go further? No, because 8's not a perfect what? Square. So, making sure that we have those. All right, just pausing for a moment. How are we doing? You don't like that method? Okay, but some of you, this is going to be a really great method. For some of you, it's going to be like, Gregerson, I know that something squared, plus something squared is going to give me something, like it's not there, like it's complicated for you. I never teach this in my pre-calc class. But if students use it, I'm like, go for it, as long as you get your problem right. Because remember in math, are there more ways, as long as you're mathematically correct, sometimes to do the same thing? Yeah. So always follow Mrs. Gregerson's method. I don't know if that's always the best. It's just my scary mind how it works, okay? But for me, when I look at these, I don't need to do this. But it doesn't mean that if you do, you're wrong, okay? So let's look at this one. Let's try it again. It says m to the 4th minus 3m squared minus 10. Okay, now let's use the u substitution method. First of all, when I look at this, is there a greatest common factor? No. Notice I ask that every time. Why? Because guess what you're supposed to ask every time? Does it have one? So what's going to be our u this time? We're going to let u equal m squared. Okay, because we know that's really m squared squared. Okay, so we plug it in, so we get u squared minus 3u minus 10. Now, I must confess, this method is great if you're taking a higher level calculus course. You're going to need to know this method. But that's in what? 3 different classes from now. Then you need to understand it. But make sure we got this one out. What do I do now? Count the what? Terms. How many do I have? So what do we try? Yeah, logically, because they're so insistent. All right. What are my signs? Plus, minus. Okay. What are my factors of u squared? Factors of 10. Where am I putting the 2? Where am I putting the... All right, so we double check. Outside's a negative 5u. Inside's a positive 2u. Did we get negative 3u? Yes. All right, now we're at the spot where we can plug it in. And the answer is what? Yeah. So now we plug it in. We plug in our m squared for u. And then our u here, we got an m squared minus 5. Ask yourself the question, can I go further? No. What do you guys think? Not too bad? No. Someone goes, Berger said, I don't know if I really need it with those. I don't know if I really need it. Let me give you a side example of this. What if I gave you something like, I'm going to give, basically, oops, didn't want to move that over. Something like this. How about x to the 6th minus 3x cubed minus 10? You can either use u substitution for this, or you don't have to. What do we know about any even numbered exponent? It's a perfect square. What's the square root of x to the 6th? X cubed. Do you see where I know where that's going? So in my head, I'm like, okay, I can do this. There is no GCF. But I can look at this and go, oh, factors of x to the 6th, which one am I naturally going to use? X cubed. Would you guys agree with me on that? And then we can go, oh, what do we do next? So we're going to sit there and do the exact same thing, plus or minus, because it's subtraction at the end. And then we go here, 2 and, all right, I have to ask the question now. Oh, wait, there's 2 terms. This time I got cubes, but is it a sum or difference of cubes? Is 2 a perfect cube? Is 5 a perfect cube? No. What are my perfect cube numbers? 8, 27, 64. Like, you see, like, you want to know those. But could I do that one with u substitution? What would be my u for it instead? Let u equal x cubed. Then could you do it? Are you seeing how you need to claim the method that works best for you? Because are they both correct? As long as you show me, this is for some of you, it's going to be huge work. Show me work, you're good. With me on that? Show me work. All right, now look at the next one. A lot of people, and again, I look at this, I don't need it. This is probably the time that I think using u substitution makes the most sense. When I look at this, I have a quantity, 3a plus 5 squared, minus 18 times the quantity 3a plus 5 plus 81. Now, you could FOIL that first one out, distribute your negative 18, put it all together, and then factor. What if we can save some time? This time, when you're working with it, you would want to do the following. Let u equal what this time? The quantity this time, exactly. I want this to be our 3a plus what? 3a plus 5. So then when I rewrite this, what do we get? U squared minus 18u plus 81. So what do? We put the u in right there. Now what? No GCFs, would you guys agree? So it's 3 terms, so logical trial and, okay. What do we do next? So we go ahead and put in our signs. I don't know why I skipped the D, but oh well. Let me put it in there. We have, what are my signs? Right? Same sign, both subtraction. And then is it pretty easy one to write down? What do we have? U minus what? 9. And then we got U do I have to do? We have to substitute what? Back in. So now we have to plug in our 3a plus 5, go minus 9, and then go here, our 3a plus 5 minus 9. Now, I would love to say that you are finished at this spot, but you're not. What do I have to do? Is it okay to keep it that way if I can simplify more? You always have to simplify more on this. So when you're thinking about it, you really have a 3a plus 5 minus 9. And you really have a 3a plus 5 minus 9. Okay, what does that give us? Right on. 3a minus 4 in both of those. Now, you can leave it like that, or you're going to find later it's nice to rewrite it as a quantity being squared. It helps us when we're graphing polynomials later. Now, this one's okay, right? I just want to make sure you understand those are the same type of idea. You need to go further. Okay, let's go back and see if we can do C real quick. Didn't realize I totally skipped C, but you know, that's what I do. Yes.
We do have to label up at the top, like saying let you.
Yes, very good. Great question. Caleb goes, if I use this method, do I have to tell you let u equals? And the answer is absolutely.
And you still have to put the parentheses even if you're doing the quantity.
You don't have to put the u in. I would always put the parentheses in when I'm substituting it in. Always. Because that will help you keep track of signs. Because what if it's at the end, not the beginning? All right? I'm going to show you one that we always do with our pre-calc advanced ones. And if you guys can do that, your life is like rocking. Okay, let's go back to C. This time, remember, it's really nice that we're able to do it. So what are we going to let our u be this time? Yeah, so we're going to let u equal the quantity 3a minus b. And I'm just putting the parenthesis there because I think it's going to help you to remember. Put it in when you're working with it. So 3a minus b is what? U squared minus 6 times what? U plus. Now you always do the normal ask. Is there a good stomach factor? No. How many terms? What do we have to use? Yep, logical trial and error. What are our, yep, subtraction for both, awesome. And then we go, okay, factors of u squared. All right, factors of 9. Yep, 3 and 3, because if we add them together, we got negative 3u and negative 3u, so that gives us negative 6u. All right, so we're going to plug it back in now. Now we have to substitute in what we have. So that's the quantity 3a minus b minus 3 times the quantity 3a minus b minus 3. It's always good to plug in with the parentheses, especially when it's more than just a single variable. And then we got to do the math. So we got 3a minus b minus what? And we know it's going to be 3a minus b minus 3. Is there any simplifying we could do with that? No. So that one is as good as it's going to get. Look how nasty that looked. Okay. But we could also write it as 3a minus b minus 3 being joy, right, my friends? Okay, let me give you an example of a u substitution that we do in pre-calc. All right, so we're going to do it on the top of here, okay? So this would be a chance of working with it. And it's a slight change, but I think you're going to understand. Again, I don't need to do u substitution because I recognize patterns. So here's another one. Factor the following. The quantity x minus 5 squared minus the quantity y plus 7 squared. Now, a lot of students freak at this. They're like, oh, I can't do this. But honestly, what is it? How many terms? What are we doing with them? Squaring them. Isn't that just a difference of squares? But that freaks people out. Well, what do you do when it's something nasty looking like this? 2 different variables. Well, friends, guess what we do? We let u equal x minus 5. And then we're going to let w equal y plus 7. You can use 2 variables if you need to. So when we're looking at this, you're going to have a u squared minus a what? Oh, do I have a greatest common factor? Oh, how many terms? So what are we going to use? Difference of? We got to do difference of squares. So on this one, you're going to have a u plus w, and you're going to have a u minus w. Now you're at the spot, you got to do what? Plug it back in. So when we do this, what goes in for you? Parenthesis and x minus 5 plus w, which is a y plus 7. All right, that looks horrible. So let me move it a little bit more over here. Plus y plus 7. Maybe the quantity x minus 5 minus the quantity y plus 7. Now notice, parentheses are really important with simplifying this. On the first one, do I need those parentheses at all for adding? No, so that becomes an x minus 5 plus y plus 7. Next one, my x minus 5 is fine. What do you have to do? Subtract, right? So that means I need to distribute that negative through the whole quantity. So minus y minus 7. Now you simplify. What do we get here? X plus y plus 2 times the quantity x minus y minus 12. You see why maybe substitution process is good for some number of problems like that. Again, for me, I go straight to this step because I know if I use my parentheses, do I have my quantities being squared? Guys, that's why it's really important to understand this method. Higher level calculus problems, if you don't use substitution, you're not able to do the math with it. But we gotta make sure that we have it. Okay, now we're gonna do one last term, and then we're just gonna practice today. All right, we're just gonna practice grouping like crazy. All right, so we didn't get to go to this method. We talked a little bit about it on Tuesday, which feels like forever ago. Does that not feel like a long time ago? But we're working with using a process where we have 4 terms. And if you guys remember it, you worked with it last year, 2 years ago, called factoring by grouping. It's really factoring by a large GCF. Is really what. And I think you guys will get it. But you have to have 4 terms. All right, we're going to just do a quick review of taking out a common factor first. So we're going to do factoring by grouping. All right, first of all, what's the first thing you always look for when you're factoring? Okay, now I want you to look carefully at this one. Please don't overthink it. Is there a greatest common factor? What's my greatest common factor? Yep, an x minus what? 2. Do I square it? No, but that quantity comes out, right? Your greatest common factor this time is x minus 2. So I pull it out, I get an x minus 2. What gets left? I have a quantity in x minus 2 what? Is it squared to the first power? What is it going to be? To the first, right? Because this would be to the first, that would be to the what? First. So we got that down to the first power, so great. And then what do we get left when I take out the x minus 2? Plus what? Think we can do this again? We can. But the problem is you're going to be creating those terms so you can pull out the greatest common factor. Now, I've kind of thrown out 2 cool things at you. Well, let's actually practice now the skill of using factoring by grouping. And we're going to do lots of practice with this. So just know that this is probably not even enough of the process to work with it. But notice, guess what's the first thing you still have to look for? But you have to make sure you look at it in all 4 terms. Is there one in this one? No. Okay? Since not, then you count the terms. How many terms? Guess what? The only option for you to try is factoring by grouping. Now, here's what I mean by factoring by grouping. First things first. Step 1. look only at the first two terms and look for greatest common factor with the first two terms. What is the greatest common factor with the first two terms? Very good. It's a 2x squared. You got to look for everything, right? So we take out a 2x squared, and what do we have left here? So we get x minus 5. Now, here's the cool part about this. The x minus 5 is what we're going to use as a greatest common factor. So my whole goal is I need another x minus 5 somewhere. So what you do is you look at the second 2, but what you do first is you just go, all right, I'm writing an x minus 5 down. Then I ask, what do I take out here to get the quantity x minus 5? What can I factor out? Positive or negative? Sometimes you take out a negative, which makes it a subtraction problem. Please hear me on this. The number one error people do is not put the plus or minus sign there. And then they mess it up. If you remember to put a plus or a minus sign there, you're going to be fine. Because now I want you to look at this. How many terms did we just turn this from? We turned it from 4 terms now down to what? 2. Now looking at those 2 terms, do I have a greatest common factor? Yeah. Our greatest common factor is going to be what this time? Easy. Are you guys remembering this method a little bit more now? Nope. Is it a hard method so far? I don't think so. So we take out an x minus 5. Guys, and here's how easy this is to figure out. If you remove this x minus 5 right here, what's left? Yeah, and if I take out and divide out an x minus 5 here, you get a plus 3. Now you ask yourself this question, can I go further in either one of my quantities?
Yes.
X minus 5, can we go further? 2x squared plus 3, is that a difference of squares? Some are difference of cubes? So are we good? Those of you who do factoring by grouping for factoring trinomials, do you see how it's really the same thing? It's really like you use this process. Okay, let's look at the next one here. First of all, is there greatest common factor? No. So, how many terms do you look at first? First 2. Is there greatest common factor out of the first 2? X squared. So we take out an x squared, and what do we get left? X minus 2 now becomes, we know that's going to be our GCF that we're going to try to get. So I go over here and I adjust right, leaving space right here for an x minus 2. But then I ask myself, what do I do to my negative 9x plus 8 in order to get the quantity to be a positive x minus 2? What do I factor out? Now, what do? Take out our GCF, because now we created 2 terms, and then we're like, all right, is there a GCF? Yep. There's an x minus 2 times, what do we get left with? Are we done? Oh, we're not? Why? That's when you look again and always ask, look at the individual parentheses. X minus 2, is that a difference of squares? Or some difference of cubes? No. But x squared minus 9 is what? Difference of squares. Now, when you're doing this, that means you have to bring your other factor down, and then we keep on going. All right? Difference of squares out of x squared minus 3. What goes in my parentheses? And now you've gone all the way. Now, guess what was some of the top problems on that worksheet that you guys did? Some of you just didn't go further. Okay, let's keep those there. I want to give you a couple more examples of factoring by grouping. So let's see if I can find some. What pages are on? 42 and 43? Yeah, I think. I'm trying to see what, I know, wouldn't that be nice? I'm trying to see if I can find an easy one. All right, here's an easy one. Guys, try this one for me. Let's make this example 3. okay? I think this is easy, easy. You're going to do great. Okay. 5x cubed plus x squared plus 5x plus 1. Go for it. Some of you like this because it's really fast and easy first. Some of you have to think through the process a little bit more, but once you get the routine, it's not bad. All right, guys, was there a greatest common factor for this?
No.
No, but if you don't check, guess what's going to show up on a homework problem? Like a greatest common factor, and then you don't take it out, and you make yourself more miserable with it. But with this one, in the first two terms, is there a greatest common factor though? Yeah, so we got here x squared times what? Plus 1. So I want a 5x plus 1. Now here's the cool thing. Do I already have that? So what do you factor out that won't change it? Positive or negative? Plus 1. Are you guys with me? You've got to put the plus or the minus sign down. Then we just created two terms that now have a greatest common factor. What do we factor out? Yep, your 5x plus 1. And then we get our quantity, our x squared plus 1. Ask yourself, can I go further? If this was a minus 1, would I have to? But hey, it's plus 1. We'll take it. How are we feeling? Want to do one more?
But it has to be something.
No, the homework's not even that long. No. All right.
But like, please.
Let's do this one. All right.
Just one more.
Let's do. Ooh, I like this one. Okay. This is not on the homework, but it'll work. Okay. Factor the following: 5y. Let's go to the. I'm gonna go fifth. Minus 5y to the fourth plus 5y cubed minus 5y.
Okay, you messed me up. Why'd you do that? Why'd you do
No,
that?
I'm doing the homework.
No. Because she went from 3 to 1. Why? I don't get it.
Oh, actually, let's do. Did I want to do that? Oh, no. I want to go square. Hold on. I want to make sure I have a square. I want to square it down. I think I got it the way I wanted it to go. That's what I get for thinking them up off the top of my head. If you don't do something first, you're the one who makes yourself miserable. What do you do first? Mm-hmm. It's a push, but I think you guys can do it. What do you do first? All right, take out a what? The rule doesn't change. Always look for a greatest common factor first. Is there one here? What is it? So I'm taking out a 5y squared. First thing you do, rewrite everything. What do we get left with? Y cubed minus y squared plus y minus 1. Then we ask, are you done yet? And you say, no, because I have how many terms? 4. So now this 5y squared comes along, and I always change this to brackets to make my life a little bit easier. But then I'm like, okay. First 2 terms do have a greatest common factor. So I get y squared times the quantity what? Y minus 1, which means I have to have over here a y minus what? All right, so what do you take out of a y minus 1 to get a y minus 1? Plus 1 or minus 1? Mm-hmm. Great. So now I'm going to bring this 5y squared down, and now I'm actually ready to put my parentheses in. Take out your greatest common factor. What do you have? Y minus 1. What gets left over if you take out your y minus 1? Ask yourself, can you go further? Can we on any of them? No. Then you're not. All right. I think we need to practice all types of graphing. Let's get going with it. I mean, factoring.
Whoa.
Am I helping you?
Whoa.
Just get markers.
You scared.
All right.
She said.
We need to practice. Got to get this down, guys. We've got 15 minutes of this, so we're going to go really fast. Graphing's actually going to be the last of this.
No.
Can you guys make sure you get that?
What? Yeah. Who are we passing this to?
All right, I'm going to stop the notes. We'll do
All right.
practice.